All right, this is going to be the Unit 1 through 4B Final Review, Take 1 review. We're going to begin with ACAS 1A. So from 1A, this is the Delta Math title that you can go and practice for these kind of questions. So this is write explicit and write recursive. So we have a picture, and again, they can be different things. It could be numbers, it could be a picture, it could be a graph, it could be a table. The important thing to realize that this is the first one, this is the second one, this is the third one. So what I just did is I made it a table by hitting plus table. All right, now before we even go into this, what is explicit and what is recursive? So if you look at your notes on the right hand side of your page, you'll see that it's in your formula sheet. The only thing is, of course, they're not going to tell you what everything is. So I'm going to just describe everything really quickly. This is a to the nth term. So this is the a nth term. This is a sub 1, which is the first term or the initial. D is the common difference. So when you subtract the second minus the first, you'll get that number. And then n minus 1. Okay, explicit formulas can also be written in function notation, y equals mx plus b. You'll see that in just a second. For the recursive one, okay, you have a sub n again, so which is the nth term. Then the difference is you have the d, which is common difference. And then here, instead of having a sub 1, you have a sub n minus 1. And all that means is the 1 before. So you take the previous term and you do something to it. So take the previous term and then something to it. All right, so once you have the two formulas, all right, you start off with whatever you're given. So if you're given numbers, you'd put the pattern in terms of a table. If you're given a picture, you would just go ahead and count those boxes. So the first one has 1, 2, 3, 4 boxes. The second one has 1, 2, 3, 4, 5, 6, 7 boxes. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. And again, if you were just given a sequence like of numbers, they would give you something like this: 4, 7, 10. So again, it's the same thing. This is the first one, this is the second, this is the third. First, second, third. All right, once you have that in there, okay, we are writing function notation, explicit and recursive. So function notation is simple. We just click the flag. There's my function notation. Y equals 3x plus 1. So find that answer there. Y equals 3x plus 1. All right, now we can also write that as an explicit formula. So there come several ways of doing this. We can do it forwards or we can do it backwards. When you have multiple choice, you can type in all the answer choices and see which one matches this one. Okay, so we're going to go ahead and do that, but I'm also just going to show you how to do it forwards because it's also quite fast. So explicit formula says take the first one, and what was my first one? My first term was 4, right? Plus the common difference. The common difference, remember, is the same as slope. Okay, so common difference is slope, or you can think of it as a second number, which is 7 minus the first number, 4, which is 3. And you can see that slope and common difference is exactly the same thing. 3, and then parentheses, and then you have n minus 1. All right, so that is actually the explicit form. So I can go and find out which one matches that. All right, so that's recursive. Here's explicit. I'm looking for 4 plus 3 n minus 1, and that's this first one. Now, to confirm it, we are going to put this in the calculator because remember, anytime we have multiple choice, we're going to type everything in and then see what matches. So I'm going to leave this here. You can see there's an error here. Try adding y equals. So I'm looking for it to match, all right, my original line. And you can see that that matches because that's the answer, right? So we're going to type in everything else. So 3 plus 4, and I'm really just going to type the same thing and just change the numbers. So 3 plus 4, n minus 1, does that match? It does not. So I'm going to come into the next one, change the numbers, 4 plus 3, and then this one is n plus 1. Does that match? It does not. Going to the last one, which is 3 in no parentheses plus 4. Does that match? It does not. So the only answer is this. So I've shown you how to write it both forwards and backwards using the calculator. But no matter what you do, you always check your answer with the calculator. Okay, it has to match. All right, to write the recursive one, again, we're going to start off with the previous term plus the common difference. Okay, so the previous term plus the common difference. So I don't know what the previous term is, so I'm not going to write a sub 1 minus 1, but I know the common difference is plus 3. So I'm looking for this exact thing plus 3 is what I'm looking for because the common difference is, again, the slope, or you can take the second one minus the first one. All right, so I'm looking for something plus 3. All right, so the first term is going to be what? 4. So if I look here, there's only 2 options. There's F and there's G. All right, and then I'm looking for it to say plus 3, and the formula, be very careful with what it says, is n minus 1. N minus 1 plus 3. So that's what the one I'm looking for. So the 2 options that I have is one is saying n minus 1 plus 3, the other one is saying n plus 1 plus 3. So just be very careful to make sure that you're really looking at that. And so that is the answer. So again, the most important thing to remember whenever you're dealing with explicit, recursive, or function notation is that you need to know the slope is the common difference. How do I find this common difference? The second number minus the first number. So for example, let's say that they gave you this as a graph. So they'd give you these options. So you'd go and see, hey, what's my first term? My first term is 4. You put it in a table. Hey, what's my second term? It's 2, 7. Put that in the table. What's my third term? 3, 10. Put that in a table. Or they can give you as a pattern, 1, they can write 4, 7, 10, or they can give you as a picture. So again, all those are the same representation. The process is the same. Make a table. Look at what the linear regression is. The slope is the common difference, and then plug it into the formula sheet, or you can just plug in the answers and see which one matches. All right, question 1b. Now that I know that says fill in the blanks, the 25th term is. So I know that this, I take my function, or I can have it in explicit formula notation, it doesn't matter. And then I want to find the 25th term. What do I press? I press settings, table, and I'm looking for the number 25. I have the 2 options. I can press enter, 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 enter until I get to number 25, which is taking a long time, or I can just type the number 25. So the 25th term is 76. The blank term is 40. So this time they're not telling me which term it is, but the something term. So my x value is when y equals 40. So I'm just going to look down these, and I'm going to see right there the 13th term. Okay, the 13th term is 40. So they can either, in these kind of questions, they can ask you, what if I give you x, what is y? Or if I give you y, what is x? Again, the key thing is to make it function notation, make it a table, press enter, enter, enter until you look for what you're looking for. All right, so number 2, we're going to go from recursive to explicit. So we've talked about how you can be given a pattern, a graph, or some kind of picture. Now we're going to be given one of these formulas, and you have to go to the other one. So let's go ahead and do recursive to explicit. That means I'm given this one, and I'm asked to write it like this, okay? So given the recursive, so again, it's very important to realize, what do you know in recursive? You know the previous term, and then you're given the common difference. So once you're given the common difference, you know that common difference is the same one that goes right here. And anytime they give you recursive, they must tell you the first term. So the first term, the common difference. So all you have to do is take those numbers from this formula and put it into the explicit form. All right, so let's look at our question. Given the recursive and arithmetic sequence to be A1 is -5. So again, that is the first term. I'm going to go ahead and clear my calculator. All right, so my first term, so again, here's my table. My first term is what? -5. I need to know what my second term is so that it can give me some kind of linear regression, right? So I can write the explicit formula. So how do I find that? Well, I need the common difference so I can know what the next term is. So again, let me just remind you. So it goes previous term plus the common difference. And that's the same common difference that we put right here. Okay, so if you look at our question, previous term -3. So the common difference is -3. So that means I start off with -5. I subtract 3. It's going to give me my next number, which is -8. Now, if I've done this correctly, when I hit this, you should see the common difference of the -3 that we started with. Let's see. It is. Because remember, slope is common difference. So again, they gave me the first term. I use my common difference to go from my first one to my second one. I double check to make sure that my common difference is my slope to know that this is correct. And then again, I have one of 2 options. This is multiple choice. Since I did it by hand last time, I'll do it by typing it in. You're going to type everything in, and you're looking for whatever matches. So -3n -5. Okay, there's an error, so click on that. Try adding y equals. So let's try adding y equals. Does that match? It does not, so that's not it. I'm just going to copy and paste this to the next line. -3, this time try +5. Does that match? That's not it. Next line, -5 here, then -3, and then in parentheses, n minus 1. Does that match? We have a match. Okay, so this is the answer. I'm just going to double check the last one to make sure that that does not match. So this one is -3, like that, n plus 1, and then -5 at the end. Does not match. So the only one that could match is this answer choice. So this is our correct answer. All right, and again, we could have done that by hand because again, you know what the first term is -5, the common difference is -3. So if you were just writing that out, you would start with, and I'm just going to write this, the first term, which was what? -5, plus the common difference, which is -3, and then parentheses, n minus 1. And you can see that that matches our answers. And if I try y equals, you can see again, it matches. Okay, so you can write this forwards or you can type it into Desmos to see which one matches. So that's how you go from recursive to explicit. All right, now that I've done that, what is the 15th term? Well, once you know your answer, remember, all you have to do is make it a table. So I'm just going to take one of these answers. So both of these are correct. I'm going to make these a table. And I'm looking for the 15th term. So again, two options. I can press enter, 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 enter until I get to number 15, or I can just type number 15 and I can see that that is -47. So that answer is D. All right. And so as we've talked about previously, they could tell us the X value and ask us to find the Y value, or this says fill in the blanks. The blank term is -50. So what they're saying is, I don't know what X is, but I know Y is -50. So I look down my Y and I look for -50 and I don't see it. So that means I need to press enter some more. So when I go to press enter, you can see it's blank because I stopped the sequence. So what I'm going to do is delete the 15 I did and just press enter, enter, enter. And I'm looking for there we go. There's -50 right there on the Y. So when Y is -50, this is the 16th term. So again, in these questions, they can give you X, find Y, or they can give you Y, find X. The important thing is to make it a table and press enter, enter, enter. All right, so that's taking care of 1A. Before we go on to 1B, what you're going to do is pause the video real quick, make notes to yourself. So you'll see this is question 1, right? And this is additional notes question 1. So obviously you have the explicit formula, recursive formula. Okay, what's the question asking you to find? So you're answering the question here. How will Desmos be helpful? What's the work? What's your answer? And then rate yourself on this topic. So basically you're making additional notes because you will not have this video at your disposal. So you will have your notebook that you can just turn to. And question number 2. Okay, so now we're going to go to 1B, which is question number 3. Interpret linear function, and that's cut off. Interpret linear function coefficients. Again, each time I'm doing this question, you're writing notes to yourself. What's that question asking you to find? How is Desmos helpful to you? And you're just writing notes to yourself that you can read back on and understand how to answer the question. And then what's your work and your answer, and then rate yourself on how you feel on this topic. And remember, these are titles for the actual Delta Math. So you're going to actually go to Delta Math and practice these so that you know how to do them. All right, so 1B. All right, suppose an athlete wishes to burn 700 calories a day by running and swimming. He burns 17.5 calories per minute of running and 12.5 calories per minute of freestyle swimming. Okay, so there's two things that he's doing. Let X represent the number of minutes running and Y represent the number of minutes swimming. And I said that, but then I wrote f of X. So remember, f of X and Y are interchangeable. One is in function notation and one is in what I call 8th grade math. The equation f of x equals -1.4x plus 56 represents a combination of running and swimming. What that would allow him to burn 700 calories. All right, what does the coefficient 1.4 represent? Okay, so right here, 1.4, what does that represent? So if we look back at our formula sheet, this is a linear formula, so we can see it is in the form of slope-intercept form, y equals mx plus b. Remember, m is the slope or the number that keeps happening, that keeps repeating itself over and over. B is your initial value, your y-intercept, or the number that happens one time. So once you know that there's a negative relationship between running and swimming. So X is the number of minutes running. So I'm actually going to highlight that so that I just keep track of that. So X is running and Y is swimming. Okay, so for every additional Y, X is going to decrease by negative 1.4 in order for this person to be burning 700 calories. So for every minute spent swimming, the X, which is running, is going to decrease by negative 1.4. Okay, so we're just going to write that down. For any extra minute spent running, he will swim 1.4 minutes less in order to burn 700 calories. Okay, so because there's a negative relationship with X, it says for every 1 extra minute that I am swimming, okay, I'm going to decrease my running by 1.4. Okay, what does the constant 56 mean in this context? So remember, 56 is the number that you start off with, which means it's my y-intercept, and my y-intercept always happens when X is equal to what? To 0. So a couple of ways that you could write this. It just is really up to you. So you can write it the way I'm writing, or you can write something different. So if this athlete, if the athlete runs 0 minutes, all right, because remember, this is when X is equal to 0. And what is X? X is the number of minutes running. So if the athlete runs for 0 minutes, he will swim, because that's my Y. So when X is 0, Y is equal to 56. He will swim for 56 minutes in order to burn, and I'm not, okay, I don't have space, but you can always write it over here as well, right? Because that's actually where you're supposed to be writing it. In order to still burn that 700 calories. Okay, so when X is equal to 0, which is when he runs for 0 minutes, Y is what he will swim for 56 minutes for him to burn 700 calories. All right, what does the x-intercept represent? So when the x-intercept, and again, you can write it on the next page, is when Y is equal to 0, X is equal to, and for this one, I actually need to put it in the calculator to see what X is equal to. So let me go ahead and do that. So we have negative 1.4x plus 56. And I want to see what is it when Y is equal to 0. And this will take me forever. I could solve the equation. Oh, there it is. All right, 40. So when X is 40, Y is equal to 0. Okay, so when X is 40, Y is equal to 0. When X is 40, Y is equal to 0. So again, you're just writing this again. So remember, Y is swimming and X is running. So you're just simply writing, and I'm not going to write this out, so you go ahead and write it. For if the athlete runs for 40 minutes, he will not swim at all in order to burn 700 calories. Or you can write in a different order. You could say, because Y is swimming, if the athlete swims for 0 minutes, he will need to run for 40 minutes in order to burn 700 calories. And you can rearrange that sentence however you want to rearrange it, as long as you have Y, which is swimming, and X, which is minutes running, in your sentence with the numbers and the athlete. Okay, then finally, what is a reasonable domain and range for the function? Okay, so I'm gonna, since I already put it here, I'm actually going to bring it over here. So what is domain and what is range? So just to remind you, domain is X values from left to right. And again, these additional notes, really, you should be putting them over here. I'm just being a little bit lazy and writing them in the same place. And then range is y values or y-axis from bottom, and this order is very important, to top. Okay, so the bottom to top. All right, so now look at the graph. Now remember, this is an athlete, this is a real world situation, so can I have negative? Okay, can he run for negative time? No. Can he swim for negative time? No. So none of these negatives exist. So I'm really only looking from here to here. Okay, those are my only options. So because those are my only options, domain is 0 to 40. Now the question I have for you is, can I include 20.5? Yes. Okay, so 0 to 40, he can run for 20.5 minutes, right? So because he can do that, these are all real numbers from 0 to 40. So there's a way we can say that. So we can write it like this, from 0 to 40 inclusive, or we can say all real numbers between 0 and 40. Okay. All right, what about for the y-axis? The bottom is going to be 0. The top is going to be 56 inclusive, because we can run for 0 or swim for 0. So 0 to 56 inclusive, and it's all real. And again, I'm just being lazy to write this. All real numbers between 0 and 56. Because some of the questions will say, okay, you cannot have 20.5. So because you can't have 20.5, it has to be 20, 21, 22, 23, 24. So that will be integers. All right. Or how else will they write the whole numbers? Okay. But in this case, you can have everything in between. So it's all real numbers. All right, so again, pause the video and write some notes to yourself as to how you're going to remember what goes with what. And that is AKS 1B. All right, so we're going to take a look at AKS 1C. This is only talk about domain and range, and we did that in the last AKS as well, but we're going to do it again. So again, what is domain? And please write your additional notes over here. I'm just going to write them where it actually is if I have space. So domain is the x-axis left to right. And then range is the y-axis bottom to top. Okay, so a water dispenser is emptying. So this is a real world situation. And remember, anytime there's real world situations, it restricts the graph. So if I was to type in this equation into Desmos, I'd see a graph, but it doesn't restrict it. But you have to remember that because it's a real world, it has to be restricted. So this water dispenser is emptying at a constant rate every hour. So here's the amount in the dispenser, and you can see that it cannot start with negative time. So I can go ahead and just cross this out, because that doesn't make any sense, because I can't have negative time. And then, of course, as it's emptying water, what's going to happen after 10 hours? It's completely empty. So it's not emptying any more water. There's no negative water in there. So that's going to also go away. So again, just remember, with real world situations, there are restrictions. And then also there are restrictions within where you are. So if I look at 1, 2, 3, 4, you have to ask yourself, in the context of the problem, can you have 1.5 of whatever this is? In this case, it's hours. So yes, I can have 1.5. But if this was like people, I could not have 1.5 of a person. So that would also restrict these in between, leaving just the whole numbers or the integers. But in this case, because it's hours, I can have 0.5 of an hour. I'm allowed to have that. What about an amount in the dispenser? Can I have a decimal amount in the dispenser? Yes. So I can have all of this and all of this. In this case, this graph is continuous, meaning that you can have everything in between. All right, so this is the function: interpret each characteristic listed using the given context, choose an answer from each category. All right, so let's talk about, since we're just looking at domain and range, let's talk about that first. So domain is your x-axis left to right. Remember, we already canceled here because of lack of negative time. So we're going to start at 0 and we're going to go to 10, and we're not going to pass 10 because of this. And it's going to be decimals and everything in between, and that's what I'm looking for. So automatically I can see this is y. I'm not going to do that. Here's an x1 between 0 and 10. So this one is right. Let me just read the rest. The dispenser is filled every 10 hours. Nobody said anything about that. It's going to be empty in 10 hours. the M is 0.1, the dispenser empties by 0.1 gallons per hour. I mean, that might be true, but what is it asking? It's asking for domain, which is left to right from 0 to 10. So again, it's just being careful to answer the question. So this would not be the answer because it has a Y value. So it has to be D. All right, for range, it's the bottom to top. So again, we've talked about cannot have negative, but we can have all of these and everything in between, and nothing exceeding 5 because it starts off with 5, whatever, gallons or whatever this situation may be. So from 0 to 5 is what I'm looking for on the y-axis. So 0 to 5 on the y-axis, yes. So this is going to be it. But let me read the explanation, just make sure. The dispenser initially has 5 gallons and empties down to 0. Yes, it does. Okay. Why is this one not it? Because it has this X in between. 0, 5, this is just a y-intercept. The dispenser fills up from 0 gallons up to 5 gallons. This is true. This is the right explanation, but this is a coordinate. 0, 5 just means the y-intercept is 5. M is equal to 5. The dispenser empties at a constant rate of 5 gallons per hour. That might be true, but again, actually it's not true because this is negative. But again, we're not looking for slope, we're looking for the range. Okay, so that's domain and range. So let's look at slope. So before I even look at my answer choices, I need to know what slope is. All right, so I could put this graph into the calculator and have it tell me what the slope is, but I'm going to identify it from our formula sheet. It says y equals mx plus b. The number with the x right before the x is your slope. So we can see here that my slope is negative 1/2. But again, if you did not know that, you could always plug in a couple of points. So you can put in 0, 5 and you can put in 4, 3 into the graphing calculator. So making a table, 0, 5 and 4, 3, and that's going to give you this equation, and you can see that your slope is 0.5, and you bring that right there, make it a fraction, negative 1/2. Okay, so just in case you didn't know how to, I guess you still kind of have to identify it from there, so I guess you still have to do that. All right, so we're looking for the slope is negative 1/2, so negative 1/2, I'm going to read that in a second. It's definitely not that one. It's definitely not that one, and it's definitely not this. And let's read the explanation. The tank is emptying by 0.5 gallons per hour. That's true, because this is the hours, and it's emptying, it's going down by 0.5 gallons every hour. So my A would be my slope. My y-intercept, where it crosses the y-axis, is going to be 5 right here. This is my y-axis right here. Okay, so my y-intercept. So I'm looking for 5. So let's first find that. So it's definitely not that one. And it's not this one because this is 5, 0. So it's one of these two. And now we just have to read the explanation. The dispenser empties at a rate of 5 gallons per hour. That may be true, but again, it's got nothing to do with the y-intercept. And of course, it is also not true because we know that the slope is negative 1/2. So that's not it. All right, the dispenser started with 5 gallons of water. Yes, so remember my y-intercept is what do I initially start off with. All right, so again, you're going to write notes to yourself. How did you find domain and range graphically? How is Desmos useful? You're just writing additional notes to yourself here to help yourself answer these questions. All right, AKS 1D. All right, we're writing equations from lines as our Desmos practice. A rental car charges a flat rate of $100 plus 5 miles per mile driven. Write the equation for C of X given the context. Be sure you know how to write the equation from context and the graph. From context and the given graph. Okay, so it's saying you need to know always. Okay, so I need to know how to write it from context. I also need to know how to write it from the graph. So let's talk about from context. From context, remember, I'm looking for the number that keeps happening over and over. And then I'm looking for the number B, which happens one time. So a rental car charges a flat rate of $100. Is that the number that happens one time, or is it the number that happens over and over and over again? Well, it's the number that happens one time. So that's the plus B. So that's going to be plus 100. And then I'm just looking for the number that keeps happening, right? Plus $5 per mile driven. So that means every mile I drive, it's going to be $5. So mile 1, $5. Mile 2, $5. Mile 3, $5. Mile 4, $5. Mile 5, $5. Mile 6, $5. Okay, so you get the idea. That's the number that keeps happening. So I've written the equation from context. Okay, but it's also saying make sure you know how to write it from a graph. So how do I write it from a graph? So I'm going to do plus table, and I'm just going to put in those points like I did in the previous question. So this is 0, 100. So knowing all representations, because you don't know how they're going to ask you. And then find me another corner. This is a corner right here, 20, 200. So 20 and 200. And I only need 2, but I can just confirm. 40, 300. What else do I have? And 60, 400. But I only need 2. And that should match exactly what I wrote from context, which it does. So this is writing equations of lines given a graph, which is you put in a table with the points and see what the equation is from context, okay, which I didn't write over here, but I'll have it written on your copy. That's recognizing what's the number that starts off with or happens one time, and then what's the number that keeps happening. Both methods could be asked, or even from a table. And if it's from a table, you just put in the table and then look at it. All right, so looking at that, just make sure you match up the answer and that it looks like this. Now this looks a bit steeper, and that's because it's zoomed out a lot. We can definitely make it look flatter like this, but basically you're just looking at, it starts off at 100, 20, so here's 20, 20 is 200, and if I did this right, 40 is 300, is 40, 40 is 300, yep. So, and again, you remember we can also, and you don't have to do this, but we can make this the same as this. So my x-axis, I want it to go in tens, and my y-axis, I want it to go in hundreds. That way it puts it kind of like how the graph is, so it's a little bit easier to see and faster. Okay, and also, let me also show you, remind you this, take out minor grid lines, it gets rid of that as well. And then you can also make it fit. So let's do from 0, let me actually match this from 0, from x-axis, it goes from 0 to 60. And this is unnecessary, but I'm just going to put it in here just in case. 100, well, not 100, starts off at 0, 0 to 400. And this should look very, very similar to the graph, 400. All right, and I'm going to zoom out, and you can see, let me hide this a little bit. All right, so you can see it's more of a flat line to that one. So again, that's how you kind of work the settings, but you don't need that to do this question. So you just match in 5x plus 100. Make sure you choose the correct one. That answer is B. Once again, go ahead and write some additional notes. So we kind of talked about, this is writing equations from a graph and also from context. So we're going to go ahead and put that delta math in as well. Right, so this is unit 2, starting off with AKS 3A and 3B. They kind of go together. One is writing the single from context, then graphing and looking at possible solutions. So Avani and her children went to a grocery store and they buy peaches and mangoes. Okay, so remember, you need to highlight whatever it is that's happening. So you're buying peaches and mangoes. Each peach costs. So there's my first number, highlight. And each mango costs, there's my number, highlight. Avani has a total of $15 is my other number and my keyword to spend on peaches and mangoes. Write an inequality that represents possible values for the number of peaches purchased and the number of mangoes purchased. Okay, so this is, again, seeing what this is representing is the number, not the cost, but the number that you're purchasing. All right, so again, you write out your words. So calculator does not take P, right? But so we're going to put X, but every time I put X, I'm going to remember that that's P. So I'm going to go ahead and write it here. This is X and mangoes is Y. All right, plus 1.5 Y. And then what does the word total of $15 mean? That means my mom gives me $15 to spend. I can't spend more than that. So this is going to be less than or equal to. I am allowed to spend the $15. I just cannot spend more than what I don't have. So this is my inequality. So now we're going to graph it after we write it. So this is 0.25. And I'm not going to write X and Y because it tells me P and M. So I have to use P and I have to use M. 1.5 M is less than or equal to $15. All right, so that's my inequality. Let's graph it. All right, so again, to graph it, I just need to find some corners. So is this a corner right there? Yep, there's a corner, 0, 10. So that's a corner right there. Let's see if there's another corner on the x-axis. Now, there is a corner on the x-axis, but it's obviously too far gone. So now I just have to find another corner. So again, easiest way to find corners is you're going to zoom in until it's going up by 1. So this is going up by 2, 1, 2, 3. Okay, there you go. And then now you're just looking for the corners. And if you're doing this, remember we can hit settings and get rid of the minor grid lines. And that way we can quickly see that this is a corner. All right, now in case you forget to do that on the test, I'm going to do it with the minor grid lines still on here. So again, I'm looking for a corner, and the corners are these big boxes right here. This is a corner. You verify it by clicking on it. So 6, 9. So you're going to come 6 on the X, 9 on the Y. So point right here. See if we can find one more just for practice. So again, you're looking at this big box. Right here is another one, 12 and 8, and you can see that's off the page. All right, so this is the inequality, solid line. So solid line, boom, 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 going like that off the page. All right, so now that's my inequality. What are my solutions? So remember, stay away from what? Dotted lines. And whatever you think your solutions are, you can just double check it by putting it in Desmos. So I'm going to put in 0, 10 as the first one because it says 0, no peaches and 10 mangoes. Is that a solution? Yes, it's on the dotted line. And you also have to think through, this is a real life situation, right? So can I have negative, what was X again? Peaches. Can I have negative peaches? No. So you're not going to have any of this, right? Can I have negative mangoes? No. So none of this. So basically in quadrant 1, in this first quadrant right here. All right. So 0, 10, 16, 8 is another one. So again, I'm just going to type in all of it. I'm not even going to bother typing 50.5. Why? Pause the video and think of, why am I not going to type in 50.5? Because you can't buy half a peach. That's not possible. So we already know that this is definitely not there. All right. Now I'm also not going to type in negative 6 peaches. Why? Because I can't buy negative. Because this is a real world context. You're not just looking everywhere where it's shaded, you're also looking at it in the context of the prompt. So I can't have any negatives and I can't have any decimals. All right, I can type the next one. So 30 and 5. And then the last one is 60 and 0. All right, let's zoom out and let's see what we got. Okay, so green, no, 16, 8, not a solution. Why? Because it's not in the shaded area, so no. Blue is fine. What this purple one, why is that one okay? And let's always zoom in to make sure. Why is this one okay? Because it's a solid line. So if this was a dashed line, it would not be a solution. So that is a solution. And where is my black one? There's my black one. Is this one okay? Always zoom in to double check. Yes, it is, because I can have 60 and 0. All right, so those are my 3 solutions. So 0 and 10 mangoes. So I can have 0 and 10. I can have 16 and 8. I can have 30 and 5, and I can have 6. No, actually, I couldn't have 30 and 5, could I? I couldn't have 16 and 8. So I highlighted it and then I wrote it. Sorry. So I'm only putting my highlights: 0, 10, 35, 60, and 0. So just be careful when you're transferring your answers over. Oops. All right, so those are all the possible ones. Why can't I have 16 and 8 again? Because 16 and 8 is not in the shaded area. That's 30. This one is 16 and 8. You can see it's not shaded. All right, now we're going to do that for 2 lines. So that was a single, right? A single one. So can you write it from context? Can you graph it? And also, can you tell me what the solutions are? So now we're going to try a system. So as always, you're going to type it in. Y is greater than or equal to 2x minus 8. And then the second one, y is greater than negative 1 divided by 3x plus 6. Always double check to make sure you typed it in correctly. We're going to transfer it over to our paper. And again, the key fact being that one is solid, one is dotted, and where the overlap is. So again, I'm going to keep doing this for you real quick. Where do both shades happen? So not just the red, but also the blue. So red and blue, red and blue. All right, you should have seen it over here. So anything in here, stay away from the dotted lines, but solid is okay. Can I do this one? No, I can't do this one because it also is on a solid, is on a dotted line as well as a solid line. All right, and then be careful about real world situations. This is not a real world situation, so I can go over here. This is a solution. I can have negatives, I can have decimals. It doesn't matter because it does not tell me a real world. All right, so let's go ahead and transfer this over. So again, click hide one of them, and let's see if we can get, okay, that one's not on my graph. I'm just looking for the good numbers. 40 is on my graph, so 40. All right, and then let me find another one. Again, zoom in so that you can see the points. Here's another one right here. I think 6, 4. So 6 and then 4. And all you need is 2 to make a line. And this is a solid line. So just do the best you can. A solid line. All right, don't shade it because we're only going to shade the answer. Sometimes the question wants you to shade both. Sometimes it just wants the answer. So just keep in mind. All right, so now let me do this other line, and I'm going to change my color. So you can use a pencil and a pen, for example. All right, let's get a good point, 0.6. So 0.6 right here. And I just need one more. Obviously, the x-intercept is too far out. There's no 18. So I just need to find me a nice corner. So make it go up by 1. So this big box is what I'm looking for. This should be a corner right here. Again, the big box is what I'm looking for, which is 3, 5. Or you can come to settings, hide minor grid lines so you can see it very clearly. So this is a corner, there's another corner, there's another corner. And then you just confirm it by clicking on it. So 3, 5. Put the grid lines back because in case you forget that on a test. So 3, 5. All right. And I'm actually just going to see the intersection just so I can make sure I can make this as accurate as possible. It intersects at 6, 4. 6, 4. All right, so this one is a dotted line, so do your best to draw a dotted line, something like that. And we have agreed that the intersection happens over here. So anything in here, stay away from what? Dotted lines. Okay, anything inside there, stay away from dotted lines. All right, so the point 6,4. So 6,4, is that a solution? No. All right. Not for both, but only for one. So let's read. Is a solution for inequality 2. So let's name this. I do apologize. This is inequality 1, and this is inequality 2. All right. So inequality 1, that's this red solid line. So this one is 1, and this one is 2. All right. So now let's read the answer choices. The 0.64 is a solution for inequality 2. No, it's not because that is a dotted line. So, no. The 0.64 is not a solution for this system of linear. Yes, it is not a solution. Okay, so that's true. And I don't know if this is select all that applies, so I'll just do X's and checks. All right, it's not a solution because one of them is dotted. The 0.64 is the only solution for this system. No, it's not. It is not a solution. The 0.64 is one of many solutions for this system. No, it's not. Okay. So that answer choice is B. Okay. So again, just remember real world, you can have negatives, decimals, everything. Non-real world, I'm sorry. Real world, you have to actually check. So let's do one where you have to actually write it down. Aubrey runs a farm stand that sells apples and raspberries. Each pound of apples sells. So there's a number, and I'm going to highlight it with what it stands for. Each pound of raspberries sells. So there's another one. Aubrey made at most $124.50. So again, with the keyword. From selling a minimum, there's another keyword, of 80 pounds of apples and raspberries, right? A system of equations that could be used to represent the number of pounds the apple sold and the number of pounds raspberries sold. Define the variables that you want to write to use this. All right, so remember, money, 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 money. So I see money, money, money. Those three go together. So let's put those in order. 1.75. And I'm going to define the variable as A is equal to, and I'm just not writing this out, A is equal to the number of pounds of apples sold, plus 125 is our next number. And that's going to be for raspberries. So R is equal to, and this is me being lazy, number of pounds of raspberries sold. So R, and then our keyword is at most with the money. At most, that means the most I can have is this. I can't have anything more, so that means I have to have less than or equal to $124.50. So that's my first inequality. I've used all three of these numbers. How do I use the fourth one? I'd go apples plus raspberries is equal to that last number. And now I'm looking at the keyword a minimum. So what does minimum mean? Think of minimum height. The minimum height I can be is 80, which means I have to be either 80, so that's equal to, or above 80. So greater than or equal to. So that is how you write your system of inequalities. And have space to fit in whether things are solutions, but I'm going ahead and put it in. And remember, the calculator doesn't recognize A and R, so you just have to remember that X is number of pounds of apples sold and Y is the raspberries. All right, so for this one, again, remember you're looking for the overlap where purple and green overlap. They overlap in this section right here. This is a real world problem, so you remember you cannot have, well, can I? Can I have negative X? And X is my first one, which is apples. The number of pounds of apples. So can I have negative pounds of apples? No. So I cannot look for any solutions over here. Then can I have negative Y, which is negative number of pounds of raspberries? No. So I can't be here or here. And I can't be here or here, so I have to stay right in here. Now, my question is, can I have this one? Yes, in this case, I could have this one because they're both solid lines, so those are solutions. All right, so again, anything in this purple area, on this green line, on this purple line, where they intersect, as long as I don't go past here and I don't go past here, negative side. So just anything here between this area here is your solutions. Let's practice.